Hello guys, welcome to another tutorial session of applied electricity. Yes, before we start, right, I'll advise you to watch the previous video if you haven't. Look at it. The previous videos are very helpful. Once you watch it, you understand all that we are doing. I don't know the situation whereby you come and watch the middle of the video and at the end you feel like, oh, this is not interesting. So try as much as possible to watch the previous videos. And I believe if you watch and you understand, you like what we are doing here. Are you okay? I'll put the link of the previous videos in the description. So try as much as possible to look at the description below and watch them. Click on the links and watch them and understand them very well. And to those who are really following me well, I'm not expecting you to get less than what? 80%. The 80% here is for you. I'm not expecting you to get less than 80% in applied electricity. Okay. If you really follow me, very well, and you understand the concept very well, you are not going to struggle analyzing a circuit. Okay. So try as much as possible to follow me and get the concept. And those who have not yet joined the Telegram page, please, I'll put the link in the description. Try to join the Telegram page so that if you have any question, you can put it there. I've blocked the comment section here. I've not been reading comment section on YouTube. So if you have any question, please join the Telegram page and ask the question. If you are struggling joining the Telegram page, I've attached my WhatsApp contact over here too. Yes, I have my WhatsApp contact there, and I'll be expecting you to send me a message. Once you send me a message, I'll add it to the Telegram page. And once you join, you can ask any question there. If you come across any difficult question and you want me to help you solve it, you can send me the image over there, and I'll quickly treat it as an emergency and help you solve it. Okay, so to set the ball rolling, today our lesson is going to focus on how to convert a delta to a Y, right? And a Y to a delta. You get it? So let's start. First of all, we are going to learn how to convert a delta to a Y. You get it? If I have a circuit, right, part of a network which is having, let's say, a delta based resistor connections. So I have resistor connection, that is R1, R2, and R3. They are connected in a delta mode. You get it? So how do we convert it to a Y? So to convert it to a Y, you need to draw a Y network within. So at each corner, a Y resistor comes there. Then we label it as, let's say, RA, RB, and RC, right? So how do we find, we already know the R1, R2, R3. They'll give us the values. So we know the values there. So now we are going to find the RA. So how do we find the RA? RA is simply the product of the adjacent resistors. So if you look at RA, the resistors that are closer to it are R1 and R2. So that will be the numerator. R1 multiplied by R3, sorry. So R1 multiplied by R3, all divided by what? By the sum of all the external resistors, which are what? R1 plus R2 plus R3. Do you get it? Yes, so that's the concept. So if I want to find, let's say, RB, right? What are the adjacent resistors? If you said R1 and R2, then you are right. So those are the resistors that are closer to what? The RB. So that will be the product of what? R1 multiplied by what? R2, all divided by the numerator remains the same. So the sum of all the external resistors, which are R1 plus R2 plus R3. Then what about RC? The adjacent resistors are what? R3 and R2. So the numerator is going to be the product of R2 and what? R3, all on what? R1 plus R2 plus R3. So that is it. If I have a delta connection and I want to convert to Y, to find the value of RA, RB, RC. This is the formulas that we use in finding the values. So if I want to find RA is simply multiplying what? The adjacent resistors as numerator, all divided by what? The sum of all the resistors. So it's always multiplying the adjacent resistors divided by the sum of all the resistors. Do you get it? Okay, so let's also look at the formula for converting Y to what? Converting Y to delta. So if I have a Y network and I want to convert to delta, how do we do it? So let's draw our Y network. Let's say I have one resistor here and I have another resistor here which are connected in Y. Do you get it? So this is RA, RB, and RC. IoT. So once I have this, I'll draw a delta around it. So I have a delta here, one delta resistor here, another delta resistor here. Okay, very good. Another delta resistor here. Okay, very good. So I have, let's call this one R1, this one R2, and this R3. So how do you find R1? It's very simple, right? We are going to find, like, let's say permutation. We are going to move around the resistors that are inside, either anti-clockwise or clockwise, anyway. So I'll first multiply RA times RB. So it's going to be RA times RB plus, I end at RB, so it's going to be RB times RC. That is RB times RC plus RC times RA. So RC, RA. So we are moving around it. RA, RB plus RB, RC plus RC, RA. That's going to be the numerator. And the denominator is the resistor which is far away from the resistor R1. So which of the resistors are far away from what? R1? That is RC. RC is far away from R1. So it's going to be all divided by what? RC. Very good. So what will be R2? The numerator is always the same for this Y delta conversion. So the numerator is going to be RA, RB, like how we did it. RA, RB plus RB, RC plus what? RC, RA. All divided by the resistance which is far away from it, which is RA. So all divided by what? RA. The resistance which is far away from it. Do you get it? And what about R3? R3, we are going to have RA times RB as usual. RA, RB plus what? RB, RC, right? Plus RC, RA. All divided by what? The resistor which is far away from it. And this time it is RB. RB is far away from R3. So we are going to get RB. Do you get it? And this gives us the formula for the conversion. Once you understand the conversion, you are good to go. You get it? So the previous video, not the previous video, but the one that we just passed, this same video, just a few minutes ago, we discussed the delta to Y. And now we've discussed the Y to delta. So if you are still struggling, please reverse this video and watch it again so that you get the concept. Once you're able to derive the formula, you are good to go. Okay. So we are going to apply this in a circuit. Let me draw my first circuit, a very complicated one. I'm going to start with a complicated one so that you really enjoy it. Okay. Let me start with a complicated one. So I have a circuit here, one resistor here, right? Another resistor here. You get it? Then I have a resistor at this point. A resistor at this point. Very good. Right. Then I have another resistor here. Yes. Then this one is connected together. No resistor there. No resistor here. Then I have a resistor here. Bravo. Okay. So this one is 4. Here is 5. This is 3. This is 10. This is, let's say, 2 ohms. IoT. Then here is 1 ohm. I'm trying to use a smaller value so that you understand the concept very well. Sometimes you can get a very big value. For instance, where I made this question, they are using a very big value. I'm trying to use a smaller value so that you understand the concept very well. Okay, so if you watch our previous video, they are asking us to find equivalent resistance. If you watch the previous video, then the first step should be easy for you. I told you that when you are analyzing a circuit, that was the previous video. I told you that when you are analyzing it, you shouldn't start from where the source is. Okay, you start from the point which is far away from from the source. So 4 is far away from the source. You get it? So we don't start from the 2 and 1, but you start from a point which is far away from it. You get it? But if you look at this, the first one is so easy to solve. Why am I saying it's easy to solve? Because that 2 resistors, they are parallel. So these 2 is parallel to each other. IoT. So you can add them. And that is going to give us 5 times what? Times 4, all on what? 5 plus 4. And this is going to give us 20 on what? On 9. Please, if let's say you get a fraction and there is a lot of decimals behind, don't convert it to decimals first. Just apply the fraction. And at the end, you get what? The right answer. A perfect answer for it. So now we've combined these two. So the new circuit is going to be something like this. Let me draw it on a different page. Okay, let me draw it here. So the new circuit is going to be something like this. I have one resistor here. And this is 2 ohms. Then I have my 1 ohm here. Right. And I have one resistor here. Right. I have another resistor here. And they are all, we combine them at this point. So we've already found this, which is 20 on what? 20 on 9. You get it? Then we have 3 ohms here, and we have 10 ohms here. You get it? So if you look at this point, we don't know whether the resistors 3 and 20 on 9 ohms and 10. We don't know whether they are parallel or they are in series. But you can see that they form a delta connection. 3, 20 on 9, and 10. They form a delta connection. So in order to make things easy, right, you need to change that connection to what? To a Y. And how do you do that? You draw a Y network within. So I have one here at this point. I have another resistor here, and it ends here, and I have another resistor here. Look at this. So I'll label it as RA, RB, and RC. Look at it. So how do you find RA? This is where you are going to apply it, the formula. The product of the adjacent resistors, which are 3 times 10, right? All over what? The sum of the resistors, which are what? 3 plus 10 plus 20 on what? On 9. You get it? And this is going to give us 30 all on what? 13 plus 20 on 9. Let me take my calculator on. So with this, what do you get? We are going to get 30 all on what? On 13 plus a fraction of 20 on 9. So this is going to give us a very huge number, which is 270 on what? On 137. You get it? Yes. So what about the RB? RB is going to be what? The product again. That is 3 multiplied by what? By 20 on 9. That's the product of the adjacent resistors. All divided by what? The sum, which is 3 plus 10 plus 20 on what? On 9. And what do you get? Let me key it onto my calculator. I have 3 times what? Times 20 on 9. On 9. You get it? All divided by 3 plus 10 plus 20 on 9. And that one is going to give us 60 on 137. Okay. Now, let's find RC here. RC, right? RC is going to be the adjacent resistors, which are 20 on 9 times what? Times 10. That is 20 on 9 times this 10. So we are going to get 20 on 9 times what? 10. All on what? 3 plus 10 plus 20 on 9. And what is going to be the value? Let me see the 20 on 9 times 10. Okay. So I have 20 on 9 times 10. We are going to get, we are going to get 200 on what? On 137. Very good. So now, we've been able to what? Eradicate these resistors. So we take these resistors off, all of them, because we've converted it to a Y. So now, let's redraw the circuit. So the circuit, new circuit, is going to be something like this. We have one resistor here, another resistor here. Then now we've converted it. Let me visit it again. Sorry. Yes. So we've cleared this one, we've cleared this one, we've cleared this one. We are going to get the Y network, right? We start from here. Let me use another ink. So we start from here. Then we have one here. Then we have another one here. Okay, very good. So this is the network. Now this is what we are having. Okay. Now let's key the values. We have 2 and 1. You get it? So we have 2 and 1. 2 here and 1 here. Then what about the other ones? The RA was 270 on 137. So we are going to get 270 on 137 here. Then we also have the RB. This RB was 60 on 137. So 60 on 137. Then the last one, which is what? The RC was over here, which is 200 on 137. Okay, we are good to go. 200 on 137. Okay, very good. So now we've seen that we've gotten a different network, and still we have some delta connection. 270 on 137 and 60 on 137 form a delta connection. The same way 270, 137 and 200 137 forms a delta connection. So you can choose any of the two, right, to convert to what? A Y. So let's convert up there. Let me use a red ink this time. So let's convert the up there. This one, you can convert it to another hot. Dot Y. IOT. So I can convert to a Y. Let me call this one RA, another RB, and RC. Right. What is going to be RA? RA is going to be the product of what? The adjacent resistors. So what are the adjacent resistors? 2 and what? 270 over 3, 137. So it's going to be 2 multiplied by what? 270 on 137. Do you get it? All divided by the sum of all the resistors around. That is 2 plus 270 on 137 plus what? 60 on what? 137. Very good. So let's compute it. So we have 2 multiplied by what? 270 on 137. You can do it along with me. Do you get it? 2 plus 270 on what? 137 plus 60 on 137. And we are good to go. Our answer is 135 on 151. You get it? That's the RA. What about RB? RB is going to be 2 times what? Times 60 on 137. These two, this RB, the adjacent resistors are 2 and what? And 60 on 137. So it's going to be 2 times 60 on what? 137. All on what? The sum of the resistors, which are 2 plus 270 on 137 plus 60 on what? 137. Very good. So RB is simply going to be what? Let me write it here. Let's compute and write it there. So it's going to be 2 times 60 on 137. And that will give us 30 on what? On 151. Very good. What about RC? RC is here. So it's going to be the adjacent resistors, which are 270 on 137 and 60 on 137. So 270 on 137 plus 60 on what? 137. Sorry, times, not plus. IOT. All on 2 plus 270, all divided by 137 plus 60, all divided by 137. So what do we get there? The final answer for that one is going to be 270 on 137 times 60 on 137. Okay, so it's going to be a very huge number, of course. It's going to be 4050, all on what? 2687. That's going to be the final answer. A very huge number, of course. So let's move on. So always, I'll advise you to change it to, let's say, fraction. Don't send it to decimal. Convert it to fraction. When you get your final answer, then you leave it in what? In decimal. So with this one, what's going to be the new circuit? Now we've got rid of this resistor, we've got rid of this resistor, and we've got rid of this resistor too. So the new circuit is going to be something like this. let me use the red, right? I have my RB here, and I have my, let me draw it on a different page. Sorry. So I have my RB here. Okay. I have my RB here, right? And I have 1, 2 here. And I have another one here, right? Then there were 2 resistors down there. Okay. So let's visit it back. Let's visit our drawing back. Yes. So 1 ohm and 270. So yes. So I have, let me use another thing. Sorry. So I have the 2 resistors here. So 1 resistor here, and I have another resistor here, and they are now combined, right? So this is how the circuit is going to be now. And let's see the values. What are the values? The RA, which is this side, was 135 on what? On 151. So we have 135 on 151. Then we also have the RC, which is 4050 and 20687. So let's keep it there. So 4050, then we have 20687. You get it? And what about the other ones? That's the RB. The RB was 30151. So we have 30 on what? 151. Then the last 2, which are what? 1 and 137. So 1, 200 and 137. I think we are good to go. Yes. So let's move back again. So this is our new circuit. Now you can see that they are very big numbers. So you can see that these 2 are in series now. You can combine it. These 2 are also in series. You can combine it. You get it? And once we combine them, you get a new circuit. You get it? So that circuit is going to be something like this. We are going to get a resistor here. Then we have a big resistor here and a big resistor here. Then it's combined. Something like this. So 30 on 151. You get it? Then we have the 135. We have 135 divided by 151 plus 1. They are in series, so plus 1. And that is going to give us, this one is going to give us 286 on what? On 151. You get it? And what about this huge number? Okay, so we have 4050 divided by what? Divided by 20687. 20687 plus 200 and what? 20137. You get it? And that one is going to give us, we couldn't get a decimal, so let's write 1.656. You get it? Here it has become too simple, but I know that most of you can solve it. So if you want to find the total resistance, you are looking for the equivalent resistance. Are you okay? So with that one, these 2 are in parallel, and they are in series with this. So with that one, let me call this R1, R2, and R3. So the general formula is going to be R1 plus R1, R2, R3. All on what? R2 plus R3. So that's it. So overall, it's going to be 30 on 151 plus 286 on 151 times 1.656 all on what? 286 on 151 plus 1.656. So that's going to be the general solution, the overall solution. Let's compute it and we see what to get. It's a very huge number, of course. So we are going to get 30 divided by what? 151 plus a fraction of, we are going to get fraction on top, 286, all divided by what? 151 times 1.656, right? All divided by 286 on 151 plus 1.656. So the overall solution to give us 1.082 ohms. I'm really tired. So that's going to be the equivalent resistance. Please, you see, understanding the concept is the most important. If you follow the video very well, it's not about the values. If you follow the video very well, you will see that you've gone through some steps. The steps are good. So follow the steps and you're going to get it right. Okay, let's move on. I'm going to solve another question, which is very popular in your handouts. That question is very popular in your handouts. For instance, I have something like this. A resistor here. That's the bridge circuit. So it's very, very popular in your handouts. So this one and this. So something like this. And I'm asked to find the equivalent resistance. You get it? So to find the equivalent resistance, you see that this is, let me write the values. 8, 15, 6, and we have 12 here, and we have 10 here. You get it? So you can see that we have two delta connections. So with this one, I need to convert one of them. I can choose the down one or up one. I'll still get the same answer. So let me choose the up one. I need to convert it to, let's say, a Y. You get it? Yes. So this is going to be RA, RB, and RC. So what's going to be RA? RA is basically going to be what? The product of 8 times 15. That is this and this. The adjacent resistors. All divided by the sum of it. 8 plus 15 plus what? 6. And what do we get? So we have 8 times 16, 15, right? All on 8 plus 15 plus 6. And it's going to give us 12, 120 on what? On 29. What about RB? RB is going to be 8 times 6. That's the adjacent ones. Adjacent ones are 8 and what? And 6. So 8 times 6, all divided by what? 8 plus 15 plus 6. And what are you going to get? 8 times 6 is 48. You are going to get 48 on what? On 29. Then what about the RC? It's going to be 6 times 15. So it's going to be 6 times 15 on what? On 20. On 8 plus 15 plus 6. IoT. 8 plus 15 plus 6. And what's the final answer? So 6 times 15 is going to give us 90. So 90 on what? on 29. Do you get it? So now, what's going to be the new circuit? The new circuit will become something like this. I have my black here already. Very good. Then I'm going to get, let me use my orange ink. So I have a resistor here, and I have another resistor. Let me draw it on a different page. Sorry. So let me draw it on a different page. Okay. So let me draw it on a different page. So it's going to be something like this. Then I have my one resistor here. Let me use that. Sorry. I want it to be clear so that everybody will understand it very well. So I'll have a resistor here, and I have one resistor here, and I have another resistor here. So that was the delta that we converted. Then now, what do we have? Let me go back. Yes. Then we have the two resistors down there. Something like this. This was here, and this was here. Right. Okay. So now what are the values? We have 12 and 10 as down. So 12 here and 10 here. And what about the ones that we converted? The RA was 120 on 29. That's the up there. 120 on 29. And the B was 48 on 29. So we have 120 on 29, 48 on 29, and 90 on 29. Very good. So that's it. So if you can see right here, 48 on 29, 90 on 29. So these values are what we had after conversion. So now that we've converted, see, now these two are in what? They are in series. And these two are also in series. You get it? So we can add them. And how do we add them? So it's going to be 48 plus, it's going to be 48 on 29 plus what? Plus 12. And what do we get? That is 48 on 29 plus 12. And that is going to give us 396 on 29, right? And we have 90 on 29 plus 10. So that one too is 90 on 29 plus 10. And what do we get? We are going to get 380 on what? On 29. Do you get it? Yes. So now that we've gotten that one, the new circuit is going to be something like this. Resistor here. We have a whole resistor here, another whole resistor here, and they come together. That's R equivalent. R equivalent. Yes. So here is going to be 120 on what? On 29. And this side, that is the 48 on 29 was the value that we had, which is 390, right? Yes, it's going to be 390. Let me do it again and see. 48 on 12. Yes, so it's 396. Yes. So we are going to get 396 on what? On 29. And this one is going to be 380 on 29. So with this one, the R equivalent, right? The equivalent resistance is going to be this is in series and star to these two. So it's going to be 120 on 29 plus the power computation of these two, which is 396 on 29 times 380 on 29, all divided by 396 on 29 plus 380 on 29. Yes, we are good to go. So let's compute it. If you are struggling, please, if you are confused on how we got it, watch the previous video. And if you still watch the previous video and you don't understand, please join the Telegram page. And once you join the Telegram page, you are going to do what? You are going to get the understanding. So please do not hesitate to join the Telegram page if the need arises. At that place, you will get me to what? To communicate with me. And once you communicate with me, I'll be able to do what? Expose you to what you need to what? To know, or any confusion. Maybe after watching the video, you'll be struggling. And once you are struggling, if you ask me a question on anything that you are struggling with, I'll be able to do what? To answer you. As I'm communicating with you, I'm computing it on my calculator. So let's find a final answer. And the final answer is going to be, yes, it's going to be 10 points. 10.824 ohms. That's the final answer.